problem is so well defined and the issues related to air quality as far as human health is also well known, why has it not taken off? Why is it that we are not able to do this large scale monitoring and take some action on it? That is the question that may be bothering you. Okay. The reason why IoT too has not really succeeded in a great manner, I see possibilities happening now, but it has not happened till now. Several research projects have been launched. The bug of air quality monitoring has caught several researchers over the years, not at all with any success, okay. No major success. You may ask why is this a problem? Even I have been trying personally in my lab for about a year now, and actually all what I am saying is from my experience of building systems and trying to do this monitoring of air quality, okay. So, please note I am going to show you something as well. So, it is all about lab demonstrations and building systems and monitoring all that. So, that is essentially what also I have been trying to do. In my personal opinion, the reason why it has not succeeded at all till now is because of one major non-financial reason, and that is with respect to calibration. So, I will put down calibration of IoT sensors. This has been a problem. What you measure now is actually the same value if you measure it after, let us say, a month or 2. So, this is one of the major problems. So, calibration of IoT sensors is an issue. Size has never been an issue. Size of these IoT sensors has never been an issue. Making it into a small system and monitoring the gases has never been an issue, but calibration has become an issue. So, what is a typical size of these IoT sensors that you want to do? I show you a board which you will get a feel, and this is a board. You will see 3 of them in a cluster. Okay, let me take this and show you. These 3, 1, 2 and the one that this dot here, these 3 are sensors which are measuring different types of pollutants, air pollutants. Size is not big actually. You can see that the diameter is a little over 1 centimeter, about 1.5 centimeters or so, and the height of these sensors is also close to about 2 centimeters or so. They are not very big, and you can see it is a small PCB and we can mount these sensors and start monitoring them. You also see 2 other sensors here, right. You see this sensor here and this sensor here, this one here, these are all 2 sensors. These 2 are not so big actually, you can see they are the size of an IC. We will have to go into the details of that and get into system design and so on, but before we move on you must know that you have different type of sensors. Not only these 2, but I can also show you another little box here. This little box, you see there is a fan here, there is a fan, there is a fan here, and if you apply voltage the fan will start rotating. It actually blows from here. This fan is used for blowing out, so it must be sucking something. So, it is essentially sucking from these vents, and this is measuring the famous, what we discussed now is the particulate matter. So, this is a particulate matter sensor. This is from Honeywell. Okay, this you can buy it at maybe 1500 or 2000 rupees, you can buy one and monitor both particulate matter 2.5 as well as particulate matter 10 and so on. So, essentially, so it is not about size, it is not really about exorbitantly expensive and all that. It is mostly because of one reason, that is the fact that these are hard to calibrate and keep the calibration on for months if not years, right. You have to keep them calibrated. Also, if you go back to these electrochemical sensors, they have a certain amount of shelf life, right, and you must find mechanisms to replace them periodically. They are expensive, compared to semiconductor sensors, they are very expensive, but when it comes to health you really do not worry about how expensive they are, right. So, you design a good system such that you know you measure it as accurately as possible. So, keep the cost out of the mind, do not worry about the cost because this is about health. So, maintaining a good calibration and ensuring that the sensors are responding or their response times are good, fast, and they are able to give you something in terms of being very accurate to what is happening in the ambient is where the real trick is about making IoT sensors a success, monitoring air pollution with IoT sensors a big success. The second problem, most of these sensors because of the way they are constructed have another issue of cross sensitivity. So, if you ask me the problems, one is calibration, the other is cross sensitivity. If you are sensitive to one gas which is based on oxidation, you are also sensitive to another gas which is almost doing the same oxidation process. So, issues of being cross sensitive to other gases really is an issue. So, we will go into that detail. So, that is another thing. So, how do you choose your sensor such that the cross sensitivity for other gases is minimized. Okay, so, these you have to bear in mind. So, when you come to calibration of IoT sensors, it is an issue. Cross sensitivity is also a not so a nice thing. Cost I am not going to put as I mentioned, but making them small compact is another thing. Okay, now any measurement you want to do, okay, any measurement you want to do with these sensors cannot be placed in a corner of a room. You can't say that okay I want to measure indoor air quality, so I am going to take this sensor and put it in one corner and let it make a measurement of what is the air quality in that. That is not going to work. It requires a flow. Okay, these sensors require a flow. Somehow you have to ensure that the sensors have a flow of air, sample of air is picked and then it is and a measurement is made. So, how do you ensure flow is there, which means you have to pump, you have to suck the air in, regulate it to whatever minimum required and then have an exhaust and then take them out. Okay. So, which means you need a flow, and that means if you want to maintain a flow you will definitely need a pump. So, you have to put a small pump, and again pump will require its own power which you have to supply, and you have to ensure that the flow does not exceed a certain numbers. See, this is a dicey question. People have said that the air flow should not be greater than 2 liters per minute. Some people say this. Okay, so, limit, this I will say is the limit, but typically when you do a measurement they do 1 liter per minute, and in fact less than 1 liter per minute, typically 0.5 to 0.8 liters per minute should be flowing across these sensors. So, in order to ensure that you do a proper measurement. So, this is another consideration. So, putting an IoT product with maintaining this flow, ensuring that cross sensitivity, calibration of IoT sensors, all this means that this is really a very interesting and fertile area for system designers like us and course participants like you to get sensitized to develop very robust systems which can do large scale spatial monitoring of air quality. Now, I mentioned to you an important point about that today the probability of an IoT sensor based system succeeding in accurately monitoring is a reality because of this machine learning techniques. Okay, machine learning techniques for calibration. Okay. So, there is a wonderful paper which we were looking up from simple techniques, statistical prediction techniques like linear regression, then multivariate regression, and then moving on to artificial neural networks, and all of that which essentially are used in the air quality monitoring, mostly for the purpose of calibration. So, let us look up that paper and understand little bit about that paper and then come back to system design and then wind up in terms of a nice demonstration. I think that is the overall view that we should take in this little module. Before we go on to looking up the paper which essentially talks about why the machine learning techniques are a sort of a mitigation for problem of calibration, we should look up what are the parameters that a country like India has to keep measuring in terms of, let us say, the number of gases that have to be monitored. So, I will take you to a snapshot I looked up in on the central pollution control board. Okay. This is, you can see, this is central pollution control board continuous ambient air quality monitoring in Bengaluru. You can look up parameters that are monitored: PM 2.5, nitric oxide, nitrogen dioxide, other NOx components, sulfur dioxide, carbon monoxide, ozone, benzene, toluene, then ETH benzene, MP xylene, O xylene, temperature, relative humidity, so on and so forth. Several other components are actually monitored. So, typically a country like ours, these are the parameters that governments set up very sophisticated equipments to measure these parameters, and these are typically done by the central pollution control board. You will see also that these numbers keep running in a continuous display also in airports, for instance, telling you what is the level of air quality at that moment is also flashed there. So, these are the important parameters. So, if you look up central pollution control board, you will get a wealth of information and you can process based on that wealth of information what is the current pollution levels, concentration levels, and if you know what is the prescribed standard limits, then you actually know how to compare. Look at PM 2.5, okay, on May 5th 2018 in the morning at 10:30 or so, you will see that concentration over 24-hour period was 80.84 micrograms per meter cube. Remember, our safe limit is 40 from Indian standards perspective. World Health Organization is 10 microgram per meter cube, and sensors that they have put in place is able to measure quite accurately to show that it is about 80.84, roughly twice what the Indian standard actually prescribes. So, like this you could read about other parameters as well. Note that sometimes nitric oxide, nitrogen dioxide, they could be mentioned either in terms of weight, microgram per meter cube, or they could also be mentioned in terms of parts per million, parts per billion, and so on. So, those are the other parameters. Okay. So, you may now ask another question before we move on to calibration and all that. The other question is, why should I study out of the parameters that we discussed, the solid fuels, agricultural residues, transportation, energy generation from coal fired plants, why would I want to worry about transportation? In fact, it is a nice whipping boy in my opinion, this transportation related things. Transportation related air quality pollution, several papers you will get. Air quality due to transportation, you will get several hundreds and hundreds of papers, including my own lab, again looking at transportation as a cause for generation of air pollutants, particularly particulate matter. In the other paper you have seen that it was discussed. You may now ask, why is everybody looking at that? For that I will show you the reason for that particular thing, and here is indeed the paper which is talking about it. I should show you the title of this paper is Environment Analysis of Petrol, Diesel and Electric Passenger Cars in a Belgian Urban Setting. So, this is the paper, and I was trying to read this paper. See, essentially there is no textbook on this air quality, I must tell you this. It is all about reading from different articles, different newspaper cuttings, and going after some links that are available and piecing things together to give a cohesive understanding of what is happening. So, essentially I have tried that only. There is no textbook, I have not really looked at any textbook, and I thought that this is important because these are very current publications that have happened in the recent 1-2 years. So, it is important for you to follow what is the actual things that are happening. So, please look up this paper, you may be able to download this paper, and now let us go back and look at that one section of understanding why automotive is a whipping boy equivalent for understanding of the air quality. Okay. So, let me quickly come to the table and you will see that. Okay. So, I think it is important to read this. Although vehicles are currently only being tested in for compliance with 5 regulated pollutants, internal combustion engines emit many times more hazardous and even carcinogenic substances which are not addressed in regulations. For example, benzene, aldehydes, 1,3 butadiene, metals and large number of polycyclic organic matters under which polycyclic aromatic hydrocarbons PAH are categorized. When we talk about pollutants which are not even being discussed, and they are just about these 5 regulated pollutants, what about these unregulated pollutants, and these are some examples. So, the United States Environment Protection Agency has listed 16 out of over 500 polycyclic aromatic hydrocarbons to be monitored in the ambient air, of which the International Agency for Research on Cancer has targeted 7 possible or probable human carcinogens. So, it is cancer causing, please note. Benzopyrene serves as the traditional marker for PAH exposure, as the total exposure is given in some unit. Okay, it is called toxic equivalency concentration. You may have to go and look up this reference for that, but that is besides the point. The table from this IARC, which is the International Agency for Research on Cancer, estimated average contributions of transport to air pollution in developed countries, and the increased contribution of air toxic in urban regions and all that have been shown, and essentially contribute to 2 to 10 times as much as in general background locations. And here is why you have to understand the transportation as a major culprit for degradation in air quality. Carbon monoxide contribution to air quality is roughly 90%, PM 2.5 25 to 30%. It is reasonable, right, because we know that there are other contributing factors which we listed can also be sources for PM. So, this is another source, and this is restricted to about 25 to 30%. Nitrogen oxides 40% is the contribution, volatile organic compounds 35%, average air toxics 21%, and urban air toxics about 42%. So, when you talk about air toxics, you talk about aldehydes, benzene, 1,3 butadiene, PAH and metals. Okay, so, these are very important. So, here is another twist to why vehicular emissions you have to read, you have to understand, and it comes in a very counterintuitive way, and this is true for any vehicle, okay, and that is what is called non-exhaust emissions. Nothing coming from exhaust, nothing because of any fossil fuel burning and all that, just because the vehicle moves, it is creating a lot of particulate matter, and that is what you see here. Besides tailpipe emissions, so called non-exhaust emissions due to brakes, abrasion of brakes, tires and road surface can be differentiated, which typically can be categorized as particulate matter species with complex compositions. When comparing internal combustion engine vehicles, either diesel or petrol, non-exhaust emissions account almost equally as exhaust particulate matter emissions by mass amounts. Compared to the uniform type approval test for PM as a regulated exhaust gas pollutant, there is no standardization for the measurement of non exhaust related counterpart. That is an eye opener, right, that is an eye opener. Okay. And concerning the influence of both exhausted and non exhaust particulate matter, a forecast up to 2020 is given in figure 5. Let us look up figure 5. So, here is figure 5. You have exhaust and non exhaust. You can see the contribution of non exhaust has been significant, and you can see this part coming down, which is already positive news. So, a lot of vehicle manufacturers are putting efforts to get down the particulate matter due to exhaust, due to burning, due to fossil fuels, but this component is going up and this is unregulated. That is really the problem. Why is this a problem? They refer to the reason for this is that fleet turns over and the oldest diesels get replaced. The growing dominance of non exhaust particulate matter is highlighted in this graph, as despite ongoing restrictions for the exhaust PM, a business as usual approach for non exhaust PM will not allow to obtain significant reductions of the total traffic related PM emissions. As mentioned earlier, almost all exhausted PM can be found in PM 2.5 range, while for this paper this share is assumed to be 100%. Coarse particles on the other hand originate from non exhaust sources such as brake, tire and road surface wear and all that. So, please note that this is also a very important thing as far as air quality monitoring is concerned. Finally, before we even delve into anything useful, you must know something about the issue related to hydrocarbons. Okay. So, I thought I will just spend some time on hydrocarbons and then we will move on with the finer aspects of how to make air quality monitoring a lot more successful. Okay. So, you may want to know what is volatile organic compounds and what is non-volatile. This paper is actually talking about that. So, let us see what exactly one means by these definitions. It is a little bit into chemistry, but it is absolutely important you know about it. Okay. Essentially, when you talk about hydrocarbons, you are talking about organic compounds which are typically carbon and hydrogen, right. And this term hydrocarbons is also used for functionalized organic compounds including oxygen, halogen, nitrogen, phosphorus, sulfur atoms and all that. Basically, the definition comes from the fact that talk about from the volatility of or vapor pressure of these compounds. So, you can see that VOC or SVOC, when you say the VOCs essentially are hydrocarbons classified as VOC, which means their vapor pressure must be very high, and you can say the vapor pressure if it is low, so that it partitions between gas phase and aerosols, then you call them SVOCs. So, they are called semi volatile organic compounds. There is no global consensus on defining the exact boundary between them, but typically if you talk about organic compounds with a vapor pressure at 25 degrees of at least 10 and 270 respectively, whereas in USA volatile organic compounds are defined as organic compounds which have negligible photochemical reactivity. But whatever be the case, there are these group of hydrocarbons. In this group of hydrocarbons, methane is something that is somewhat special. You pull it out because it has a special position due to its relatively low reactivity and consequently high ambient mixing ratios. Okay. Therefore, hydrocarbons with exclusion of methane are sometimes considered as one group, the non-methane hydrocarbons, and therefore, you will see a figure with their environmental relevance. So, let us see this. You can see methane is out contributing to global warming, then you have tropospheric ozone formation, then acute chronic toxicity, carcinogenity and teratogenity. You can see these are all about SVOCs. So, it is a nice overview of hydrocarbons in the atmosphere, subgroups, origin and all that. So, it would be good if you could also read this paper and understand a little more about hydrocarbons and also the reason why you need to measure them quite accurately. So, I mentioned to you that currently there is a good success, there is a possibility of a good success if one makes a IoT system, builds an IoT system for large scale spatial monitoring, because current machine learning tools are becoming popular for the purposes of calibration of these IoT sensors. I was recently reading an article and I thought I will point you to this article which appeared in Elsevier Sensors and Actuators. The article is called Field Calibration of a Cluster of Low Cost Available Sensors for Air Quality Monitoring. Essentially he is talking about part A, which is ozone and nitrogen dioxide. So, let us see and what are the simple tools one may use to get a big picture of this problem related to calibration. The use of low cost gas sensors for monitoring ambient air quality would reduce air pollution monitoring costs and all that. So, you can have larger spatial area coverage, especially in remote areas where monitoring with traditional facilities is cumbersome. So, he mentions about air quality monitoring is a challenge because selectivity and stability of sensors are generally found problematic. Consequently, more sophisticated algorithms for quantifying air pollution are being developed. So, this is the trick that you could apply, you have to apply your ingenuity in coming up with different type of algorithms, essentially calibration of these sensors. Now, you can see that this sentence here is actually talking about metal oxide semiconductor sensors. Several metal oxide sensors operated at different heating temperatures. These multi sensors were either calibrated against standard gas mixtures or using artificial neural networks under field conditions. Neural network calibration has been mainly implemented in the identification of organic compounds and smell, or for monitoring compounds such as CO or CH4, which is carbon monoxide or methane at high level. So, neural network has been applied here, whereas the MOX sensors, metal oxide semiconductor sensor type sensors, are known to suffer from lack of stability and long response time. They have a very long response time. So, you may have to do something else, right, in order to calibrate them successfully. A recent study describes a new real time field calibration by comparing mobile sensor responses with reference measurements of existing reference monitoring stations have coming up. So, there are a lot of interesting intelligent applications which are being done, and this paper brings us to a very interesting table of what these clustered sensors are all about. You can see the names of these sensors. Let me again expand. If you want to experiment, you may want to choose these sensors, because these are things which have been studied. There is a manufacturer called Alpha Sense, and it is measuring a pollutant like ozone. CT Tech, Alpha Sense for NO2, again CT Tech. SGX Sensotech, which has a sensor model called MIX 2710, MIX 4514 for NO2. Okay, so, how many they put into the study is interesting. Then there is another company Cairpol, there is Figaro TGS 5040 for carbon monoxide, SGX Sensor Tech Mix 4514 for carbon monoxide, and Edinburgh sensors model called GasCard for CO2, ELT sensors and so on. So, you can see this issue of multiple gases from the same sensor is evident. Take Mix 4514, you can see Mix 4514, you can measure carbon monoxide, as well as you can also measure nitrogen dioxide, both from the same sensor. You can see that you will have two sensing elements, one takes care of oxidation, the other takes care of reduction, and in the process able to measure on the same sensor both these parameters. But you also have to take care of several issues before you start actually making a measurement there, and we will discuss some of those issues in building such systems so that you get a clear idea. So, we will move on. So, you can see this article will tell you also about, this will give you an overview of these low cost sensors. You can see that they have chosen the sensors which from the table which I mentioned to you, and in this you can see that it is clearly highlighted the problem of cross sensitivity, right, it is out here. The cluster consisted of 5 NO2. For NO2 and comma MOX, for the measurement of nitrogen dioxide, both semiconductor sensors as well as electrochemical sensors were used in order to benefit from different inherent cross sensitivities of both types of sensors. Whether you take electrochemical or the other way, both of them suffer from cross sensitivity. It is important, you have to make enough noise about understanding where the problems are coming for measurement. So, as I said, the cross sensitivity calibration have been major bottlenecks for IoT to succeed in the measurement of these parameters. So, another important point is that the reason I marked it here is also important. Whenever you do system design, you have to ensure that you avoid contamination of the sensor. So, sensors are measuring gases and you do not want them to be contaminated and make them sluggish. So, ensure that they are clean when they are making a measurement. So, they put some Teflon tape to protect the electronic and to avoid contamination of these sensors. So, the other things are, people have tried to sort of go ahead to sort of prepare smart electronic circuits which will display in real time the measured value as well as the complete internal data logging from within the system. So, people have used very novel techniques to do that. Another thing that can bring down the reliability of the measurement is the effect of humidity variations. You can see that humidity variations by using a gas specific inlet filter combined with dynamic air sampling system, all these smart electronic systems which remove humidity will also improve not only the lifetime of the sensor but also improves the reliability of measurement. Alpha Sensors is another company, and you can look up Alpha Sensors, also quite popular for in application in IoT. Then of course SGX Sensor Tech, we will go into a little detail here. You could use MIX 4514 which has combined NO2 and CO sensor, and you can start measuring both. Okay. You can detect NO2 and CO with two different signal outputs, and you can use a evaluation kit which is available from Sensor Tech directly if you want to make measurements. Okay. Now it brings us to a very important sentence here which sort of lays the emphasis for all measurements. Read this line very carefully. The MIX 4514 were directly soldered on the EK1 adapter by the manufacturer. Okay, trivial. Based on the manufacturer data sheet, the evaluation kits were operated in manual mode on low heating for NO2 sensors 43 milliwatt corresponding to a R load of 1 kilo ohm, and high heating for CO sensors 76 milliwatt corresponding to a R load of 256 kilo ohm. So, you can see that several things are packed into this sentence. Clearly, if you want to make a measurement of any air pollutant in a semiconductor sensor, you have to heat the sensor will need a heater. So, there will be a heating element and you heat it, you pass power, different powers in order to sense the pollutant of interest. You heat it to some level, if you want to make a measurement, the heater is taken to a different you pass a different power for lower power for NO2 measurement and a higher power for measurement of carbon monoxide, right. So that is what it is saying, and it is saying also for electronic engineers like us that there is a change in R value which is indicated by the concentration of the pollutant. Essentially R means resistor value. So this is another thing that is coming out from this. So most semiconductor sensors will show you change in concentration of level based on purely on the change in the resistance value. So this is another important point that comes into our mind. So we will discuss this, but keep this in your mind. Then there is another company called Figaro, that is also a low cost sensor. This paper is talking about calibration methods which we can discuss in a little more in detail. Thank you very much.